Hi everyone, this is Shivam. Welcome back to the second video of the series How Kubernetes Thinks. In the last video, we saw the chain reaction. kubectl sends request, the API server stores the desired state, and controller manager reacts. But we stopped at the moment a pod object was created. A pod object is not running a container. So what actually happens between kubectl apply and running a pod? So when you apply a deployment, you eventually see a pod in a running state. But that doesn't happen magically. Well, there are three major things happening. First, the pod gets scheduled to a node. Second, the kubelet on the node takes over. And lastly, the container runtime actually starts the container. Let's break this down step by step. Firstly, whenever a pod is created, it is in pending state. That means it exists, but it's not assigned to any node yet. The scheduler job is simple. It looks at all available nodes and then decides where this pod should run by checking CPU requests, memory request, and node conditions. It picks the best fit. Once scheduled, the pod is assigned to a specific node. So here is the Kubernetes architecture. As we can see, I have multiple nodes here and two control plane nodes. Control plane nodes has multiple processes running. One is the API server, second is the controller manager, third one is the scheduler, and the fourth one is the HCD, which is the database of the cluster. So every node in your cluster runs something which is called a kubelet. When it sees a pod is assigned to its node, it says, okay, I need to make it real. The kubelet doesn't run the containers itself. It tells the container runtime what to do. So the flow is simple. Kubelet talking to container runtime, and container runtime is scheduling the container. Here the container runtime, like containerd, which actually pulls the image. It downloads the image, creates the container, and then starts the process. Only then the pod moves to a running state. The best part is Kubernetes records every step and we can see that timeline. Let's head on to the demo section and watch it live. So here I have two git bash terminal and I have three pods running. So these two pods are part of a deployment. Now let's do a describe on one of the pods. Let's check the events. We can clearly see here the first event is it is trying to pull the image. Then the second event says successfully pulled image. The third event is trying to create a container which says created container nginx. And finally it says started container nginx. So first it was scheduled to a node, then the image was pulled, then the container was created, and finally the container was started. That's the chain of events. You can literally see the scheduler at work. You can see kubelet pulling the image. You can see the container runtime starting the process. It's not magic. It's step by step. Let me delete one of this pod and we'll see all the events live in action. Now before I apply the delete command, I'm gonna run a kubectl get pods command on the second git bash terminal. This --watch option will give the pod status in real time. So as of now, I can see that two pods are running. Now I'm gonna delete the first pod. Let's hit enter and keep an eye on the second git bash tab where you can see the events getting generated live. We can clearly see the pod is getting terminated. At the same time, a new pod is in pending state. Then it says container creating. Then it finally created the container and the container started running. Now if I try to do a kubectl get pods here, we can clearly see this new pod came up 30 seconds ago. So this confirms all the events happening in background when you try to schedule a pod. Now let's try to use a wrong image for our deployment and we'll see the events again. I'm going to change the image from nginx to ngginx. I'm going to save it and I'm going to reapply the deployment file. If you have been following my previous YouTube videos, you must be familiar with this replace command. It says container was replaced. Now let's look at the events here. Starting from here, it says terminating, terminating, terminating. And then it tried to create two new pods which are in pending state. Then it went into creating container state. Then container was created, but image was not successfully pulled and it gave an error image pull error. So let's try to look at the events using describe command. And we can see here it is throwing an error saying back off pulling image nginx. And here it clearly says fail to pull this image. So this clearly explains that whenever you try to create a pod, there are series of events which are happening in background before a pod comes in a running state. And these events prove exactly whatever we have discussed previously in this video. So now you have seen what really happens between kubectl apply and a running pod. First, the scheduler assigns it to a node. Second, the kubelet takes over. And lastly, the container runtimes pulls the image and start your container. It's a sequence of a very logical steps. But here is something interesting. How does Kubernetes know which pod belongs to which deployment? How does a service know which pod to send traffic to? And how does everything stay connected without hard coding things? The answer is something very simple but incredibly powerful. Labels. In the next video, we are going to talk about the hidden glue that holds Kubernetes together. And once you understand that, you will realize they are more important than YAML itself. That's it for this video. I'll see you in the next one. Till then, keep learning.